Hello, Maurieo. In this video I'm going to take a look at density. So let's crack on to it. Okay, the Greek or letter P is the symbol that's often used for density. It's sort of a italic, sort of like sloping P. I'm going to call it P, but it stands for density. M, little m, that is, lowercase m for mass, and V, capital V, for volume. And the formula for density, or the definition of density really, is P, density, equals mass divided by volume. Mass over volume. Now, there are a number of little formulae that are like this in a number of little disciplines. In electricity there's one, and there are other ones with this particular thing where you've got the three variables in this signal like that. And there is a little way that some people find quite easy to remember the various configurations of the formula, how to rearrange the formula so that you can get out each of the three features. So the way that you do it is you draw this little triangle. So you draw an equilateral triangle, unlike the triangle that I've drawn here. That's one where all three sides are the same. Through the middle you draw a horizontal line, and then halfway for that line down to the base. Then you put M for mass in the top, the P symbol for density, and capital V, like so. So if you want to work out any of the three variables, mass, density or volume, you put your finger on the value you want to find and read the equation. So let's just test it out with the definition one there. So you put your finger on the P here, put your finger on there where the mouse is, and then read off the equation. So P equals mass over volume. Alright, so that seems to work for that. Let's look at the next one. I want to find mass. Put your finger over mass, and that's P times V. You want to put your find the volume, put your finger on the volume, and that's equal to mass over density. So that's a pretty simple little thing. Rather than sort of working it all out, it can be done just remembering the triangle and putting your finger on whatever you want. So let's put that to use and see what we can come up with. So here is our first little sample problem that we're going to look at. The mass of an object is 3.7 grams and its volume is 7.26 cubic centimeters. Calculates its density. So density is what we want to find. Put your finger on density. It's equal to M over V, mass over volume. So let's work with that. We've got 3.7 is our mass, grams. Put the grams out here, and 7.26 as the volume, it's centimeters cubed. So P is going to be equal to 0.5096. That's just 3.7 divided by 7.26, and then from here we can see it's grams per cubic centimeter. Now I have rounded that to 0.5 grams because I have just to the one decimal place there, because the lowest count of the data is one decimal place here. Okay, 3.7 grams. This is 3.726, but this is the lowest. You know, the least accurate measurement is the cutoff for what we round to. So one decimal place here, one decimal place here, and then we can write it as grams per centimeter. It's centimeter grams per centimeter cubed. Remembering that if we take the centimeter cubed, at the moment that's grams over grams over centimetre cubed. If we want to bring it all up to one line, we just change the positive to a negative. So that's grams per centimetre cubed. And that's to one decimal place. So let's have a look at another one, a little different one. An object has a volume of 0.37 cubic meters and a density of 5,000 kilograms per cubic meter. Find its mass. Well, here you go. Put your finger over the mass here, and you've got that's equal to PV, density times volume. So here's our mass, our volume 5,000. We've put the kilograms per cubic meter there, times 0.37 cubic meters, and we multiply 5,000 times 0.37. That gives us 1850, and we can see that the cubic meters cancel out, and it's kilograms, which is what we'd expect from a mass. 1850 kgs. Okay, I haven't rounded or done anything to that. It's just the way it comes out. And finally, we come to a problem here, which is probably a bit of a two-step problem. If 1200 cubic centimeters of gas with a density of 0.008 grams per cubic centimeter condenses to a liquid with a density of 1 gram per cubic centimeter, what is the volume of the liquid? So the first thing here is to look at the gas, because we've got two bits of information about the gas. So that tells me that I'll just go here and find out what information I've got. I've got the volume and I've got the density, so I haven't got the mass. So let's find out everything about the gas first. So we'll find out its mass. Put your finger on the mass, okay, and you can see that that's equal to the density times the volume, which is in this case 0.008 times 1200. We've got grams per centimetre cubed there with the density, and centimetre cubed there with the volume. So the centimetres cubed carries out, we get 0.96 grams. So that's the mass of the gas, which it's in grams, so that's what we'd expect. So we know everything about the gas. So now let's go and have a look at the liquid and draw up another triangle, and this obviously here it's going to have the mass, the liquid will have the same mass as the gas, and we know the density of the gas, of the liquid, 1 gram per cubic centimetre, because we were given that. So that just leaves the volume to find out, which, and funnily enough, is what they asked for in the question. So there we have the volume equals M over P, just by putting your finger over the volume. And let's fill in the formula. 0.96 grams over 1 gram per cubic centimetre. Now, because that's over grams per cubic centimetre, that will in fact cause it to reverse, and so when we put it on the straight, so centimetre cubed over grams, when we flip it around the other way, the grams cancel, so we get 0.96 cubic centimetres. So this was grams per cubic centimetre, but it was over, it was on the bottom, so when we just change it to the reciprocal, multiply up to the top, just to reinforce what's happening there. So there you are. That's just pretty much density in those three problems, and the little triangle relationship there, which helps us to work out whatever formula we need.